Earth is a snowball? Sounds wild, doesn't it? But what if I told you there's concrete evidence suggesting that our planet was once entirely frozen over? This isn't some sci-fi movie plot. It's one of the most groundbreaking theories in Earth's history, the Snowball Earth hypothesis. And guess what? This global deep freeze might have been the spark that ignited complex life as we know it. Stick with me, because we're unraveling the most extreme chapter of Earth's history, one discovery at a time. All right, let's set the stage. The Snowball Earth hypothesis suggests that between 720 and 635 million years ago, Earth went through not one, but two intense glaciation events, the Sturtian and Marinoan glaciations. These weren't your average ice ages. No. We're talking about glaciers miles thick, covering the entire planet, even down to the equator. Imagine Earth looking like a giant frosty orb floating in space. Scientists believe these icy epochs weren't just freak occurrences. They might have been triggered by volcanic activity or shifts in Earth's orbit. But the scale is what's fascinating. Ice covering every continent, oceans frozen solid, and a planetary deep freeze lasting tens of millions of years. But how do we even begin to prove something this colossal? That's where Colorado's Rocky Mountains come in, holding a secret that could rewrite the books in this icy era. Enter the Tavakave or Tava sandstones nestled in Colorado's Rocky Mountains. This seemingly unremarkable rock formation turned out to be a gold mine for Snowball Earth evidence. Using laser ablation mass spectrometry, yeah, sounds like something straight out of a sci-fi lab. Researchers dated these rocks to between 690 and 660 million years ago. Here's the game changer. Colorado back then wasn't where it is now. It was smack dab near the equator, as part of the supercontinent Laurentia. The presence of glacial deposits in an equatorial region flips everything we know about climate on its head. How could ice exist in what's supposed to be a warm tropical belt? These sandstones don't just tell a story, they scream it. Massive glaciers once crushed them under immense pressure, leaving behind physical proof of their icy grip. These findings aren't just a win for Snowball Earth believers. They crack open a much bigger mystery about life itself. Now, let's zoom out a bit. The Snowball Earth hypothesis hinges on two massive glaciation events, the Sturtian, lasting a jaw-dropping 60 million years, and the shorter but equally devastating Marinoan glaciation. Together, they reshaped the planet and possibly life itself. These weren't isolated events. Evidence for them has popped up across continents, Namibia, Australia, North America, to name a few. And here's where it gets mind-blowing. These ice ages were so extreme, they might have reset the entire evolutionary clock. This survival story isn't just impressive. It's essential. Because once the ice melted, the stage was set for something extraordinary, the rise of multicellular life. If you're wondering how anything managed to survive Snowball Earth, you're not alone. Early life forms were essentially trapped under ice, cut off from sunlight and nutrients, but life is nothing if not stubborn. Scientists believe that tiny pockets of open water near volcanic activity or cracks in the ice acted as refuges. Think of them as survival bunkers for algae and microbes. These hardy organisms clung on, adapting to extreme conditions that would make modern humans tap out in minutes. This survival story isn't just impressive. It's essential, because once the ice melted, the stage was set for something extraordinary, the rise of multicellular life. With the thawing of Snowball Earth came the Ediacaran period, a time when life went from basic to breathtaking. Single-celled organisms evolved into multicellular ones, paving the way for complex ecosystems. Why did this happen? Scientists think the extreme conditions during the freeze forced life to innovate. The lack of nutrients, thickened oceans, and harsh climates acted like evolutionary pressure cookers. When the ice finally melted, organisms exploded in diversity, setting the stage for the Cambrian explosion, the ultimate biodiversity boom. It's like the ultimate comeback story, from frozen wastelands to vibrant ecosystems teeming with life. So what does Snowball Earth teach us? that resilience, adaptation, and a little bit of luck can lead to extraordinary outcomes. And if a frozen planet can bounce back to support life as we know it, imagine what we're capable of with the right mindset and actions. If you found this journey through Earth's icy history fascinating, check out our next video and do support. Catch you in the next video, and remember, stay curious.